Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, and good evening for everyone. Today I wanna making a tutorial of how to assemble D flip-flop and JK flip-flop on Tinkercad. The first method of this practicum is you should open the website, that is tinkercad.com. After you open the tinkercad.com, you must log in or sign up for making this account or making this Tinkercad account. The login have an many optional. One of them is login using a Gmail or Google. So after you login using your Gmail account, you can go through this home of Tinkercad. After that, we click create a new circuit. So yeah, after you click the create a new circuit, the display will be like this. Okay, so like I said before in early opening, we will assemble the flip-flop and JK flip-flop on Tinkercad. Okay, before we gonna assemble it, we can change this project to the name of our project. So I just changed the name of project to D flip-flop or D flip-flop. So yeah, the first thing of making this assemble or making a project of the flip-flop is the several tools or component. Okay, we must have several tools or components so that the circuit can run well. The first thing is breadboard. So you can using a breadboard or breadboard mini, but I'm gonna use breadboard small as the base of breadboard. So I'm gonna put here in the center, and after that we should have a voltage source. So I'm gonna take but battery to battery. Okay, so we can have 3 volt for this breadboard. We can rotate this battery into the right position to click this rotate. Nice. After that, we're gonna use D flip-flop because in this project we're gonna use D flip-flop, dual D flip-flop. Okay, we put here in the breadboard. Make sure the top and the bottom of the flip-flop is connecting each other with breadboard. Okay, do not like this or like this, but we're gonna put in the center of breadboard. After we have the flip-flop, we should have a output that is LED. Okay, so we can have two LED. The first one is for the output and the second one is for inverted output. Okay, so the last one is switch the switch. Okay, this switch is function for making a value of flip-flop. Okay, the breadboard arrangement is as follows. For the upper part, it will be connected parallel from top to bottom. Okay, from top to bottom will be parallel, and for the center of breadboard, he will be tied up and down. Okay, he will be tied up and down, but in top or bottom of breadboard, the tie will be left to the right or side by side. Okay, so the first thing we should do is connecting the battery to the breadboard. the negative going to negative. We can change the wire to the black or anything else, and the positive going to positive. Okay, after we connecting the negative and positive, we should connecting the upper of breadboard to the bottom of breadboard. Okay, the first one is click the negative of upper breadboard and connecting to the bottom of breadboard. After that, connecting the positive breadboard to the bottom of breadboard. Okay, after that, we're gonna connecting the D flip-flop to the breadboard using a wire too. The first one we should find is the power. Okay, the power is right here. Because this is a tied up and down. This is a tied, so you can click on every dot to the positive. Okay, I'm gonna click here and to here. Okay, I'm gonna change to red. After that, we're gonna make a ground to the negative. We're connecting the ground to the negative. We click here and we click here. I'm gonna change to black. Okay, after that, in the flip-flop there is no set or reset, so we should take them to the positive of breadboard. This is a reset and this is a set. Okay, I will go set and reset to go to the positive of breadboard. Okay, and the set I'm gonna take to the positive of bottom of breadboard. Okay, and after that I will gonna use the input going to the switch. Switch is functional for making a value of flip-flop. I'm gonna click right here and I'm gonna click right here in for a port. Okay, so after we connecting the for a port, don't forget to connecting the any side of switch that has not connecting to the positive of breadboard, so the switch can be active. And after that, this is a clock, so we can use something that is push button as a trigger of this project, so I'm gonna put here. Okay, and the right top of the push button I'm gonna connecting to the positive, and for the for the left of bottom in this push button I'm gonna connecting to the clock. Okay, I'm gonna change it to orange so we can see the clock and any wire. I'm gonna change the green of the value of the flip-flop to the turquoise. So yeah, and the last one is the output. After we make the project or the flip-flop, so we should have an output. Okay, the anode will be going to output 1. Okay, this LED is going to output 1 and this is going to inverted output 1, so I'm gonna change to green. Okay, I'm gonna change to green so we can see a difference between the output and the inverted output. Okay, and I'm gonna making a connecting with inverted output and the inverted output LED. The anode will going to inverted output 1. I'm gonna change it to brown maybe, so we can see difference between anode and cathode. And the cathode will be going to the negative of breadboard. I'm gonna change to black, and the cathode of inverted output I'm gonna change to black too. Okay, so yeah, this is the final of the project of the flip-flop in Tinkercad. Okay, let's start the simulation. Okay, the idle of the output is they are gonna on each other, so the red gonna on to be LED red and the green gonna on to LED green. So this is the condition of idle in D flip-flop. Okay, after we click the push button as a clock, we can see that the output are 0 because in the switch there are 0 for D flip-flop, and the inverted output there will be 1, or the LED will be going to on. So if we change to 0 to the 1 and we click the push button, the output will be going to on, or LED red will be going to on, and the inverted output or LED green will be off. Okay, so that's mean the output of the flip-flop same as the input of the flip-flop. Okay, so yeah, that is for the flip-flop. So yeah, after we making a D flip-flop, we are gonna make the JK flip-flop. So after you make this D flip-flop, you can back to the home of Tinkercad. The project will be autosave. Okay, so now I'm gonna tell you how to make a JK flip-flop in Tinkercad. So same as a D flip-flop, we create a new circuit. Okay, the display of the Tinkercad will be same as the flip-flop. We need some any component like before, that is breadboard. Okay, we put here in the middle of Tinkercad, and then second one is battery. We need two battery because we're gonna using 3 volt. Okay, we can rotate this, then we need the JK flip-flop. Okay, we put like here in the middle. After that, we're gonna use switch again for the value of JK flip-flop. We put right here. Okay, and after that, we're gonna using a LED as an output of JK flip-flop. We're gonna use two LED. The first one is for output and the second one is for inverted output. Okay, I'm gonna change it to green so you can see the difference between output and inverted output. So yeah, this is the component of JK flip-flop, same as a D flip-flop. And the push button I will put it later because this wiring will be so much important. Okay, the first thing to do is connecting the battery to the breadboard, same as the flip-flop. The negative going to negative and the positive going to positive. Okay, then we connecting of the upper breadboard to the bottom of breadboard, the positive to the positive of breadboard. So I'm gonna change to black, I'm gonna change to red. So in JK flip-flop there is no set, so we're gonna connecting the reset to the positive of breadboard. Okay, the reset right here, and I will be going to connecting to the positive of breadboard. Okay, The first thing is finding a ground and the power of JK flip-flop. The power is in the bottom of JK flip-flop, so we're connecting to the positive of breadboard. I'm gonna change it to red, and the ground will be connecting to the negative of breadboard. I'm going to black. Okay. And different with the flip-flop, the JK have two input. The first thing is J and the second one is K. Okay, the J right here and the K is right here. Okay, so we're gonna connecting D, J and K to the switch. Okay, I'm gonna use the J in 3B and the K in 4A. So I'm gonna connecting it, the K in the 4A and the J going to 3B. Okay, I'm gonna change it to turquoise. So yeah, after that, don't forget to connecting the switch into the positive of breadboard. So in the port of 4, the 4A has to be connecting with the K. So the 4B has not connecting is not connecting to the positive of breadboard. So I'm gonna put right there. Going to red, and the port of 3 or slide 3, the 3B have connected, but the 3A is not connected. So I'm gonna connect to the positive of breadboard. You can mark it the between the J and K in right here. So you can click right here and you can drag to right here and right here. Okay. So yeah, this is a J and K in the slide of switch. Okay. Okay, after that we're gonna using a push button as a clock or trigger for this flip-flop. I'm gonna put here. Don't forget to connecting the right top to the positive of breadboard. We can change it to red, and we can find the clock in JK flip-flop. So yeah, this is a clock, or yeah, this is clock 1. Okay, because we're gonna using G1, J1 and K1, so we're gonna using a clock 1. So we're connecting to the terminal 1A. Okay, I'm gonna change to black. So yeah, this is the main of the JK flip-flop, but don't forget to connecting the output to the breadboard. The anode goes to output 1. I'm sorry, this is inverted. So the red is output, so I'm gonna put the anode to the output. Okay, I'm gonna to output, and so I'm gonna change it. Okay, and the second one is green to the inverted of output. So this is inverted of output. I'm gonna change it to orange. Okay, so the cathode going to the negative of breadboard. I'm going to change to black. So same with LED red, I'm gonna change to red. Okay, so yeah, this project of JK flip-flop is done. So we're gonna start the simulation. So yeah, the idle of the JK flip-flop is right here. So yeah, the inverted will be 1 and the out inverted output will be 1 and output will be 0. Okay. After we click the push button, the value of j is 0 and k is 0. That means the output will be 0 and the inverted output will be 1. That means hold, so the value will be held by the output. Okay. After we change the j to 1 or j to 1 and k to 0, and we click the push button, the output will be 1 and the inverted output will be 0. That's called set. Okay. If j is 0 and k is 1, the push button click and the output will be 0 and the inverted output will be 1. That's called reset. Okay. So the last one, if j and k have a same value, that is 1, what's gonna be output? This is to go. Okay. So I'm gonna click the push button 3 times, 1 2 3. So yeah, the output will be going to go. So they're gonna change to 0 and 1, 0 and 1 if the push button click by me. That's it guys for the JK flip-flop and D flip-flop. Don't forget to change the project of this Tinkercad. So yeah, thank you for attention. I'm sorry if I have a mistake for the explanation to you. Thank you and good luck. Assalamualaikum warahmatullahi wabarakatuh.